Welcome to the lecture of data science. In this video lecture, we will cover the topics from unit number 4, that is sampling and estimation, and we will see the topics such as the central limit theorem, the sample size estimation for the mean of the population, estimation of the population parameters, the method of moments, and the estimation of parameters using the maximum likelihood problem, that is the MLE. So let's start with the first one. The first topic is of the central limit theorem. So we have to see that what the central limit theorem says. So it says that with a large sample size, the sample means are normally distributed. So in this unit number 4, we are talking about the population and we are talking about the sample. So over here, the central limit theorem says that when the size of the sample is large, then the sample means are normally distributed. So if we take the sample means, then its shape will be like the bell shaped. That is the shape of the normal distribution. So this is what the central limit theorem is saying. Also, it is saying that in this particular central limit theorem, the mean of the sample is very closer to the mean of the population. So we have two different parts, that is the mean. We have two different parts, that is the sample and the population. So we have some elements in the sample. So based on that element, we are calculating the mean of the sample, and we also have the mean of the population. The central limit theorem is saying that the mean of the sample is very closer to the mean of the overall population. So this is what the central limit theorem is saying. The first point is that the sample means are normally distributed. It means if you take all the sample means and if you plot the graph, then you will get the shape of the distribution just like the shape of the normal distribution. The second point is the sample mean is very closer to the overall population mean. This is what the central limit theorem is saying. Now let's see the next point of the central limit theorem. What the central limit theorem is saying, that the sample size, over here they are focusing on the sample size. So what should be the sample size in the central limit theorem? So the sample size is equal to or greater than 30 are used in the central limit theorem. So what should be the sample size? If someone asks the question that what is the sample size in the central limit theorem, then the minimum value is 30. The maximum value, it can be any which is greater than 30. So the sample size is equal to or greater than 30. Why they are talking about the sample size? Because the population is very large. Suppose there are 384 billion people in the election. Then in my sample, whether I want to consider the 10,000 people or the 30,000 people or the 2 lakh people, so what should be the sample size? So that means the sample size, and over here they are talking about the sample size. So they are talking that the sample size should be equal to or greater than 30 in the central limit theorem. Now the third point is this one, that is the central limit theorem exhibits a phenomenon where the average of the sample mean and the standard deviation is equal to the population mean and the standard deviation. So you can draw the graph like this to understand the statement. So you can apply such methods, that is you can draw the graph in various different topics. So over here I have drawn this graph, that this statement is telling like this, that is the average of the sample mean and the standard deviation is almost equal to the population mean and the standard deviation in the central limit theorem. So we have seen the example of the population and sample, that is the election voting system. So what we are doing, we are estimating, we are predicting that which party will win based on the results from the sample. So we are asking, suppose 10,000 people. So based on the 10,000 people, whatever the result is, we are predicting that result will be of the population also, that result will be of the 3,804 billion people also. But it is not same always. So over here the central limit theorem is telling like this, that is the whatever you have the sample, you will calculate the mean, the average of that, and the standard deviation of the sample will be always equals to the mean and the standard deviation of the complete population. So what are the key takeaways, that is the key points of the central limit theorem that we have discussed? The first one is that the sample means is approximately like the normal distribution. So as the sample size gets larger, the value will be tends to the normal distribution. The second one is the sample size is always equal to or greater than 30, that we have discussed. The third point is that the point that the average of the sample means and the standard deviation is equals to the population mean and the standard deviation, that we have seen the diagram. And they are telling that is a sufficiently large sample size can predict the characteristics of the population accurately. So the central limit theorem is telling that as the sample size becomes large, then we can easily calculate all the different population parameters with an accuracy, with an good accuracy. So this is what about the central limit theorem is. Now let's see the different sample size estimation for the mean of the population. So the sample size estimation for the mean of the population. So what should be the sample size for the mean of the population? So you have to see this six different points, that is the mean, median, mode, range, variance, and the standard deviation. So you all know these topics. So let's revise quickly. The first one is the mean. What is the mean? Mean means the average of all the data values. So sample mean is given like this, that is the x bar. Population mean is given like this, that is the mu. So what is the sample mean? Whatever the elements are present in the sample, you have to do the summation of all that. So that will be in the numerator. Divide by the total number of observations in the sample. So that will be your sample mean. That is each observations divided by total number of observations. So summation of each observation divided by total number of observation. Similarly, the population mean is calculated, but it is indicated by the symbol as mu. That is the sum of all the values in the n observation divided by the number of observations in the population. That is each value, the summation divided by the total number of observations in the population, which is given by capital N, and the total number of observation in the sample, that is given by small n. Then comes the median. What is the median? It means it is the middle value. So whatever observations you have, first of all, you have to arrange it in an ascending order. So over here, I have the 7 different observations like this. And over here, it is not in the ascending order. So first of all, I will arrange it in an ascending order. So now these observations are my in ascending order. So there are odd number of observations. So I will easily get the middle value, that is the fourth value, like this. So 3 on this side, 3 on this side. This is my middle value, that is the 19. So that will be my median. For even number of observations, if you have the even number of observations, suppose there are 8 different observations, then what you have to do, you will get 2 different values as your middle value. So first of all, we will arrange it in an ascending order. So we will get the 2 different values as the middle value. So suppose I am getting over here, that is the 19 and the 26. So I have to take the average of these two values. So suppose I am getting the average as 22.5. So that will be my median for the even number of observations. Next comes the mode. What is the mode? The mode means the number which is maximum appearing in your observation. It means the number that occurs with the greatest frequency. It means with the number in your observation which is repeating the maximum times. So that will be your mode. The third one is the fourth one is the range. So what is the range? You all know that it is the largest value minus the smallest value. Then comes the variance. What is the variance? It is the measure of the variability. So the variance of the sample is indicated like this, that is the S square. So what is the variance? It is the summation of, that is each observation minus mean of the sample, that is the X bar. So each observation minus mean, the whole square, divided by the total observations. So that is my sample variance, and the population variance is indicated by the sigma square, that is the each observation minus the mean of the population divided by the total number of the uh, observations. So this is how you can give the variance of the population, that is xi minus mu the whole square divided by n. So in numerator you have the summation. Then comes the standard deviation. What is the standard deviation? It is the square root of the variance. So just do the square root in the previous formula. So you will get the standard deviation. So standard deviation of the population is indicated by sigma, and for the sample it is indicated by capital S. So the sample size estimation of the population proportion is given like this. That is the formula like this. Now next comes, that is the estimation of the population parameters. So in the estimation of population parameters, we have two types of estimates, that is the point estimates and the interval estimate. So let's understand the first one, that what the point estimate is. So the point estimate is saying that you are estimating a value which is a single value, or we can say which is a specific value which can be calculated from the sample statistic. So the point estimate, they are saying that you have so many different numbers and you are estimating. Estimate means to predict something. You are estimating a specific value, a single value from various different values. That means the point estimate. Then comes the next one, that is the interval estimate. So what the interval estimate is saying, that you are estimating some values which lies between this particular interval. So over here you are not estimating a single value, you are estimating a range of values. So this range of values we will call it as the interval, and there are various different values present in this interval. Now there are so many values in this interval, so along with the interval, we have to give some probability of that numbers. So suppose in this interval, I have 10 different numbers, then what is the probability of selection of that 10 different numbers I have to give along with it. So the interval estimate, the definition is like this. That is, instead of a specific value of the parameter in an interval estimate, the parameter is said to lie in an interval, say between the points A and B, and you have to give some certain probability or confidence of that particular number which lies within that interval. So this is what the difference between the point estimate and the interval estimate is. Now, the next one is the estimation of the population parameters. We have to see the following three criteria for the quality of the estimates. So, we have seen that different type of estimates, there are two different type of estimates, that is the point and the interval. Now if you want to check the quality of the estimates, then you have to see three following criteria. So in that, the first one is the unbiased estimate. So what the unbiased estimate is telling, that suppose you have the actual value like this. So this is your actual value, that is the population parameter value, that is suppose mu. Then the estimated values lies around the actual value. So this all different black dots are my estimated values, and you can see that it lies around the actual value like this. So it has told like this, that this is the graph of the unbiased estimate. So in this, the estimates are randomly scattered around the actual value. So it is randomly scattered, and you can see that it is around the actual value. So I can write like this, that is, if x is an unbiased estimate of m, then I can write like this, that is e of x bar equals to mu, that is mu is my population parameter. So I can write like this, that is e of x bar minus mu is equals to 0 for the unbiased estimate. Now you have the question that what is the biased estimate. The biased estimate is like this, that this is my actual value, that is the population parameter value mu, and my estimated values lies over here. So you can see that all the estimated values are on one side of the actual value. So it is not around the actual value. So this is what is my biased estimate is, and you can see over here that the value that e of x bar minus mu is not equals to 0 over here for the biased estimate, and for the unbiased estimate, as all the estimated values are around the actual value in a circular manner, so you can say that e of x bar is minus mu is equals to 0. Now let's see the next parameter for the quality of the estimation of the population parameter is the consistency. So in this they are telling that the estimator of the population parameter, say x, is said to be consistent if it converges to the true value of the parameter. So suppose these are my different value of x. If I add up all these values, then it should be very near to my original value, that is my original population parameter mu. So if such things happens, then I can say that my estimated parameter is consistent. Next one is the efficiency. So efficiency is telling that an efficient estimator implies that the resulting estimate of the population parameter has the minimum variance. So if the variance is minimum, then you can say the efficiency of that parameter is good. Now let's see that the estimation of the parameters is usually carried out using the following three approaches, that is the method of moments, maximum likelihood estimate, that is the MLE, and the Bayesian estimation. So we will see the first two, that is the method of moments, and the MLE, that is the maximum likelihood estimate. So the method of moment, what they are telling, that what is the method of moment? The method of moment are the measures that is used in the statistics. Now, what do you mean by moments over here? Moments means moment is a set of statistical techniques, or we can say the parameters. It is the set of parameters which is used to measure the distributions. So in distributions, we have the different measures like the standard deviation, the mean is there, the variance is there. So that set of parameters which is used to measure the distribution are called the moment in statistics. So we have to see over here the method of moments. So the first one is the nth order moment. So I can give the nth order moment like this, that is it is the nth order, so it will be x raised to n, that is e of x raised to n is equals to each value of x, that is xi raised to n, into p of xi, that is p of xi is my probability mass function. Now over here I can write like this also, that is the integration of minus infinite to plus infinite x raised to n into f of x, where f of x is my probability density function. So if I want to find the central moments, so I can write like this, that is the value of x minus the mean value raised to n. So in this particular equation, that is x raised to n, if you replace x with x minus mu, then you will get this equation, that is x minus mu raised to n equals to xi minus mu raised to n into p of xi. So for the continuous random variable, over here the value of x is discrete, over here the value of x, that is they are considering as the continuous random variable. So over here you can write like this, that is in this equation just put down x minus mu, so you will get this equation, that is e of x minus mu raised to n, that is x minus mu raised to n into f of x. So just put the instead of x just x minus mu to get the central moment at nth position. Now the moments can be connected to the various measures of population. So the zero order moment is given like this. So instead of n, just put the 0 over here. So you will get this formula, that is x raised to 0 into f of x dx. So the total probability will be equals to 1. Now the next one is the first order moment is the mean. So always the first order moment is the mean. So instead of n, just put the value as 1. So you will get like this, that is x into f of x dx. For the second order moment, just put the value of n is equals to 2. So you will get this formula, that is e of x minus mu the whole square equals to x minus mu the whole square into f of x dx. So like this, the moments can be used for the estimating the population parameters. Now this one is the estimation of the parameters using the method of moments. So over here what we are doing, based on the sample elements, we are estimating the parameters of the population. So this is what we are talking about in the unit number 4. So these are all the things related to that. So over here what they are saying, that suppose I have the uniform distribution between the points A and B, then the probability density function is given like this, that is 1 upon B minus A. So the probability density function is this. So I can write that is each value of x into probability density function. And it is between A and B. So I have set the limit as A to B like this. So I can write like this, that is 1 upon B minus A is constant as my integration is related to x. So I can write integration of x dx. So integration of x is x square by 2. So in the x square by 2, just put the higher limit and the lower limit. So you will get the idea like this, that is b square upon 2 minus a square upon 2. So you will get the value as a plus b divided by 2. Similarly, if you want to estimate the variance, then just write like this, that is u of x minus mu the whole square, and you will get the final result as 1 upon 12 b minus a the whole square. Now, the estimation of parameters using the maximum likelihood estimation, that is the MLE. So, what this MLE is telling? So, it is the most frequently used methods. What is the main advantage because of that the MLE is used more frequently? The main advantage is over here that it is less susceptible to the individual values. Less susceptible means it will not react to the individual elements. So the individual elements, it might happen that some of the elements are out of the range, so it will not react to the individual elements, it will react to the uh, majority density. Where the majority density is present, it will react accordingly. Thus the MLE method is the robust. Robust means it works in every situation, so it can be used for any distribution. So what are the steps for the MLE? The first step is to you have to assume that which distribution it is. So suppose I am taking that my distribution is the exponential distribution in the first step. Then the second is you have to derive the likelihood function that estimates the probability of observing the data based on the distribution that you have assumed. So the second step is to derive the likelihood function. The third step is to take the log of this likelihood function. So you have to do the transformation. The fourth step is to estimate the parameters that maximizes the log likelihood function derived in the step 3. So these are the steps of the MLE. What is the first step? That you have to start with the belief about the population, that suppose it follows the exponential distribution. The second step is to derive the likelihood function. Third step is take the log of that likelihood function, and fourth step is to estimate the parameters that will maximize the log likelihood function. So this is what the steps in the MLE are. Now, if you have watched all the videos related to the unit number 4, then you can able to give the answer of such questions. So the first one is that the estimated value of parameters from a sample is called as the sample statistics, population parameter, unbiased estimator, or the sampling. You can find the answer of all these questions in the description box below. The second question is, which of the following sampling methods is not a probabilistic sampling method? So we have seen the what is probabilistic sampling method, what is non-probabilistic sampling, and we have seen the subcategories of the probabilistic and the non-probabilistic sampling. So from that video, you will get this answer. The third question is that what is the difference between the stratified and the cluster sampling? It means the previous video in that we have discussed that what is the difference between the stratified and the cluster sampling is. You can find all these questions in the description box below also. The fourth question is, an estimate of the population parameter is unbiased. So when it is unbiased, this particular topic we have discussed in this particular video, that it has the minimum variance, it has the minimum error, its expected value is same as the population parameter, or it has the minimum standard deviation. So we have discussed this in an unbiased estimate, that is the quality of the estimation of parameters. In that we have discussed this point. Then comes the central limit theorem for the sampling distribution is valid only when it is valid. So we have discussed again this topic, that is the central limit theorem, in this particular video only. So you can check the central limit theorem concept, and you can relate all these uh, options to the theory. Whichever relates to our theory, that will be your answer. So only one option will be related, will be exactly related to our theory, so you can choose the answer accordingly. So thank you for watching.